All right, so we'll get started, guys. Thank you for confirming, everyone. And what we're going to talk about today is we're going to look at how to create virtual machines inside of Google Cloud Platform, right? In extension to what we have discussed already on, first we have the network, and then we talked about like creating virtual machines. We're going to talk about a little bit more about those virtual machines today, and the service that we're going to be using. The name of the service is GCE, or it goes as Google Compute Engine. And we're going to, not deep dive, I would say, because one is not enough to do a deep dive, but we're going to look at most of the stuff that a compute engine has to offer and how to create virtual machines and how to play around with those virtual machines and do some maintenance around those virtual machines as well. And of course, we'll be taking questions as we go along, right? So if I'm not taking a question, I will be checking chat after 15 minutes of a particular topic, right? Or I'll specifically give you time to ask questions after 15 minutes. Right. Otherwise, we do have a last at the end of the session as well. We do take questions at the end of the session as well. So if your question is not answered, like at that moment, rest assured it will be answered after 15 minutes or at the end of the session. All right. So let's get started. So the first thing I'm going to talk about is, let me actually get this first. Laser pointer. All right. So what we're going to talk about is we're going to talk about compute options. We're going to talk about virtual machines, and obviously we have a demo later so that you can actually see how these virtual machines are created, right? And in fact, I'm not going to go into a lot of theory because it makes much more sense to show you rather than talk about a lot of theory. So I've tried to keep theory as minimum in the demo session as elaborate as possible. We're also going to talk about storage options. So I mean, you obviously, if you're creating virtual machines or any machine or any compute, you definitely need to have some kind of disks attached to it. So you can give some storage where you'll be storing your data, and even if you're not storing any data, you still need storage for operating system itself. So what are the options when it comes to storage, and what if you want to have additional storage attached to that particular virtual machine? How do you do that? We're going to talk about that and what are the options. We're also going to look at the pricing factors because, and this is where we're also going to talk about like different types of instances that you can create with pricing attached to them and how that benefits you as a customer to gain the maximum advantage in terms of pricing when creating a virtual machine inside of Google Cloud. And then finally, we're going to try and put all of this into perspective by doing a demo and showing you how to create a virtual machine and look at the options that we're going to be discussing throughout this particular slide. Right. So first of all, what are some of the options that you have inside of Google Cloud Platform to do computing? And I think this is something that we have discussed before as well, but let's quickly go over them again. We have Compute Engine, which is going to be what we're going to be discussing today, which is infrastructure as a service, which means you are renting out an infrastructure in the cloud, right? We have Container Engine, which has actually been rebranded, kind of an old slide, which I copied from my previous slides, but it's really called as Kubernetes Engine at this point of time. And then we have App Engine, and App Engine can be divided into App Engine Standard and Flexible. Again, as the name signifies, one is more flexible, which gives you more benefits when you're trying to create something, and Standard is something that's quite restricted in terms of deploying your applications with certain only certain libraries for that's there, which is obviously written over here, which you can obviously read through slides as well. We also have Cloud Functions as well, the serverless microservices architecture that we talked about. So you can like create something like, okay, there is an event. Let's say you uploaded something to a storage inside of Google Cloud, right? And that triggered an event, which is basically Cloud Function, which is your code. And that code says, okay, let's get the properties of that file. It's a JPEG file or it's an audio file, maybe, some custom description of that file, inserted into a database and so on, right? Things like that. Or maybe it's a file that needs some transcoding done. So it is transported into a different format and then stored back on another type of storage on Google Cloud and also stored on database. So you want that done, right? But you want that to be event driven. So when an event comes in, it triggers a Cloud Function, which basically allocates you some compute, does its job, then simply shuts down, right? And you only pay for the time that you have actually consumed the compute for. So makes your life a lot easier. So as you can see over here, you have something that is going to be running 24/7. Of course, you can manage this by shutting down the instances when you don't need them. But of course, starting and stopping instances takes their own time. And it's not as quick as like starting a small function, a lightweight function to answer to an event. If you try and do this using virtual machines, obviously that's going to be a lot slower operation because cloud functions are kind of built to do a specific job, and they're lightweight in nature instead of like loading the entire operating system from the disk into the RAM and then booting up the virtual machine and then doing the thing. So, but again, I mean, we do have all of these other options as well if you're looking for compute options, but the focus of this particular section is going to be on Compute Engine, which is 24/7 general workloads that you're going to be running, right? We do have options of scaling over here as well, where scaling is kind of inbuilt into all the other platforms, or maybe a one-click scaling, but Compute Engine doesn't come like built in with scaling, right? However, it has the resources within Google Cloud, which allows you to configure auto scaling on top of Compute Engine, right? You can either scale it up, which is increase RAM and CPUs of the instances with one click, or you can add more instances as well to make sure that you can meet the user demand as well. And then there are tools inside of Google Cloud Platform which allows you to do that, right? So coming to Google Cloud Engine, I mean, it is infrastructure as a service. So think of it like this, like, you're basically asked Google Cloud to give you your piece of infrastructure where you have first gotten a network. It could be the default network. If you have no networking knowledge, we discussed about this yesterday as well, that if you attended yesterday's webinar, then we discussed about this, that if you want to have a network, you can like get a network from Google Cloud, and afterwards you can spin up your own instances on top of this. So basically, you're renting out some infrastructure space from Google Cloud, and you only pay for the time you use that infrastructure, right? That's what infrastructure service means, that you're basically renting out an infrastructure from Google Cloud Platform, right? Then we have the actual virtual machines, and we'll talk about machine types in a bit. But first of all, I need to talk about all the things that you will care about when creating a virtual machine, right? So what all things do you need to create a virtual machine? You need some CPUs allocated. Even, if let's just not talk about virtual machines. Let's say you're trying to build a computer, right? Or you're trying to purchase a laptop, right? And what all things you'll look for before you actually purchase a laptop, right? So obviously you'll look at like, okay, how many, I mean, is it i7, is it i9, is it i3? Does it fit my budget, of course, as well, right? And I mean, how many cores does it have? And I want to make the decision based on the number of cores, because I need very high performing, which I have lots and lots of coding that I do. So I need a system which has lots and lots of CPU. So maybe that's one tick, right? Obviously you need RAM on system as well. So maybe you're running, you have some test systems that you're running, and you need more memory for those systems. For example, I do a lot of, I run a lot of machines on VirtualBox, and I need to allocate RAM separately to those, machines. So I definitely look for a laptop which has high amount of RAM, right? Then we have persistent. Then the next thing is disk. Where would you store your data, right? I mean, you need some kind of disk attached to that particular laptop as well, which is kind of inbuilt. Or if you're building a computer, you probably have to purchase a disk. Now, there are two options that you can go for. You can either go for SSDs, which are faster. I mean, if you have laptops with SSD, you'll know that they have a very, very fast boot time, whereas hard disks are super slow in terms of if you compare them to SSDs, right? Or you can have a combination of both as well. Maybe, you have a gaming laptop, you want your C drive where your operating system is with 256 GB to be, super fast. And then you have a 2 TB hard disk drive, which is slow, but that's fine. You only need that for storage. You don't need any boot operations to happen over there or any applications to run from there. All the applications are running from your C drive, but there's a D drive, which is only for storage, which is kept separately, allocated separately just for storage. Like you have lots and lots of games and you want to keep the set of files over there. That's fine. You can do that, right? So, I mean, it can be a combination of both, or it could be just one of these, whatever you need. Obviously, you need to think about networking as well. Does it have Wi-Fi? Or, I mean, in terms of laptop, I'm talking about, but when we talk about networking in terms of Google Cloud, we're talking about, the networking that we actually looked at yesterday, right? You also need to look at like what operating system are you purchasing, right? It could be Linux based, which you can just download online and then install, you're on your own, which is free. Or you can look at a Windows operating system. And the catch over there is that you have to pay for the license, right, for making sure that your Windows is activated, right? So you have to additionally pay for the license as well, right? So if you do the entire, I mean, obviously there could be other things as well, like people might also look for a graphic card in it, and they might have any other thing that they want to purchase, like I mean, there could be other things that you would probably want to purchase, but if you think about it, like if you have like vCPU sorted, your RAM sorted, your hard disk type sorted, your networking requirements sorted, your operating system sorted, and your graphic cards, if you actually need them sorted, then that should constitute a computer, a laptop that you're going to purchase, right? Same in terms of virtual machines inside of Google Cloud as well, right? When we are creating a Google Cloud virtual machine, computer engine machine, what we are looking for is all of these things to be aligned together. So we have a machine that we can use for our custom workloads. It could be anything. You might want to run a web server on top of this virtual machine. You might want to run an application server, which has, a custom application that you have created, or you might want to run a database server on this virtual machine. So you can allocate these, create a virtual machine, and then use the virtual machine to allocate any workloads that you would want to, right? And the way you get these allocation is, specifically for vCPUs and memory, the one you see over here, you need to do that by defining a machine type, right? So there is a machine type. There's a concept of machine type inside of Google Cloud. And actually, it's concept of like all other clouds as well. If you go to other clouds as well, you'll see that there's concept of machine types, which is a predefined range of CPUs, and not CPUs. We call it vCPUs. vCPUs are hyper-threaded cores, or we call it as virtual CPUs. So if you do the math is that if you have one physical core, right, that is equivalent to 2 vCPUs. So, if you talk about in terms of virtual machines on GCP or any other cloud, if you see a vCPU, so think of this as half of the actual physical core. You're getting half of that physical core, not the full core. So you take this, let's say 4 vCPUs and 16 GB, right? Or that constitutes an entire machine type, right? It could be any machine type based on the category that they have been assigned to, which we'll talk about in upcoming slides. But that will basically constitute a machine type that, okay, this machine has this many CPUs and this many memory, and that's a machine type, right? Disks are allocated separately. There will obviously be a disk that you need to allocate for the operating system, and then other disks can be allocated from the different storage types that we have, right? Picking up we already talked about networking yesterday, about network tags, public IP and private IPs. So I'm going to skip that for today in interest of time. Then the next thing is that you need to pick up the operating system, which is basically picked up by an image. So when creating a virtual machine, you need to define that, okay, this is the image that I need, right? And when you specify that image, it will already have a bundled operating system with maybe a license that you can use and pay for it, or you can even bring in your own license as well. Right. Again, bringing BYOL, bringing your own license is a different topic altogether. But yeah, you just need to remember that, yes, there is an option if you need to bring in your own license as well, that Google does allow you to do that as well. It might not be just straightforward to it, but yeah, there are options in how you can configure it, and you can also bring in your own license. But just keep this in mind. For that to happen, you also need to have your license, there is a concept called software assurance, right? So the licenses that you have purchased must have software assurance so that you can actually bring in and have a hybrid, licensing configured for your environment. If your current licenses doesn't have software assurance, which actually is purchased separately and you need to pay extra for that, then obviously you cannot have hybrid, licensing requirements met, right? So just keep that in mind. Right. So once you have all of that, that should basically allow you to create a virtual machine. Right. We'll also talk about like these machine types and these disk types in upcoming slides. But before we do that, I'm just going to quickly go over some of the GCE features. Right. So the first one is machine right sizing. Right. So after 24 hours have passed for you to have created a virtual machine, there are algorithms like machine learning algorithms based on, and obviously when your machine is running, it omits metrics. The metrics could be related to CPU. So obviously if it's running something on the virtual machine, it will, take CPU up and down based on, how much that application is using the CPU. And same applies to the disk IO as well, and same applies to the network IO as well, right? So based on that, those metrics are stored into cloud monitoring. That's a tool that is used for monitoring inside of Google Cloud Platform, another topic, right? But yeah, just think about this, that all these metrics are stored somewhere, and there is a machine learning algorithm that looks at that, and after 24 hours has passed after you have created a virtual machine, it starts making recommendations. It will tell you, okay, hey, you're running a machine which is larger in size, but you're not using it to the full capacity. So we would recommend that you downscale it. Or if you have a machine which is running low on capacity and it needs more CPU and it's always struggling for CPU, they'll recommend you a larger machine type to make sure that your workloads are not suffering or exhausted out of CPU or other resources like network or disk IO and stuff, right? Then the other thing that another feature is that, and that's also something that's just particular to Google Cloud, is that if you have, remember we talked about yesterday, like having a DR scenario where you have one machine in, let's say, US and the other one in Indian region, Europe region, or Australian region, right? But the question is that how do you redirect users, to their respective machines from their location or maybe on any other rule, right? It could be lowest latency, it could be lowest closest region or stuff like that. I mean, how do you redirect those users to the specific machine in that region, right? Normally, this is kind of achieved using DNS or traffic managers in other cloud platforms, but in Go Cloud Platform, we have a concept of global load balancing. What that allows you to do is you can just create a global load balancer and have the traffic come to the global load balancer, and that load balancer will, based on the rules that you have created, will take you to the exact virtual machine in whatever region where it needs to go. Of course, once the rule is checked and ticked, right? We have instance metadata, which allows you to add some automation on top of your machine. So if you want to go into your machine and look at like, okay, which region is this machine placed on, or what is the instance type, and stuff like that, or maybe a custom metadata that you want to upload, like a script that you want to run on boot time and things like that. You can add all of that information to instance metadata, or there is like instance metadata that is already available within the machine, which allows you to look at the properties of the instance from inside the instance. So you can use that to do some automation within the instance as well. There's also something called startup scripts. So when you are creating a machine, right, you can provide a startup script. For example, that you want to make sure that the latest updates are installed, and maybe a web server is installed, and maybe monitoring agent is installed. So you can create a script. Obviously, it has to be operating system native, right? For example, if you're using Linux, then you need to use obviously SH scripts, right? Shell scripts. If you're using Windows, you can look for PowerShell scripts or Bash scripts and something like that. And you can provide those scripts at the time of creation. And what that happens is that it runs when the machine boots, and it will do that installation. So when you're logged into the instance, you'll see that all those things are pre-installed for you and configured. Any questions so far? Okay. Then we have something called availability policies. Now, availability policies help to make sure multiple, okay, we have a question. Global load balancing multiple regions for availability. This will be automatically provided by the provider. Yes, of course. I mean, that's the whole point of using a global load balancer. Now, of course, there are some of the restrictions on what load balancers are global and what are not, right? For example, HTTP, HTTPS load balancers are global in nature, right? Whereas some of the other load balancers like UDP, they're not global in nature. But yeah, I mean, the idea is that if you're using a global load balancer, that will be automatically supported. It's a managed service and it will be supported, and the availability for the load balancer will be provided by a Google Cloud Platform itself. Right. Then we have availability policies. So now think about this. There is a situation that you're trying to let's say, not you. Let's say there is an update and Google Cloud is trying to, because underneath the hood, they have physical machines within their data centers, right? So those physical machines within the data centers, they cannot operate without downtime, right? Because there might be security updates or maybe some patching that they need to perform on those on those physical hosts itself as well, right? So what happens when they perform this patching, and what happens when they install these updates? When these updates are installed, obviously your virtual machines that are placed on that cannot continue because they need to take the machine offline. So we have a concept of something called live migrate. What that does is that it automatically takes your machine from one physical host to another without any downtime for you as a customer, and then Google can go about doing their patching on that physical host and take it offline so that no virtual machines are placed on it going forward. And once it is done, patching, it marked online, so virtual machines can further be put onto that physical host. So the idea is that if Google is doing updates on or patching on their side, that doesn't affect your workloads. And if there is something wrong with your machine, if it goes down, then there's a feature called auto restart, which allows you to automatically restart the instance, like automated way, so that if machine goes down due to whatever reason, it starts it on another physical host, making sure that you have least amount of downtime possible, or some fault tolerance built in when event happens, which takes your machine down, which could be could be due to physical reasons at the data center level or any other reason. Right. Then we have discounts, and Google does offer huge amounts of discount in terms of Google Cloud Platform, Google Cloud Engine, and this is something really huge, because even if you do not commit or reserve anything, you're still eligible for a discount, which means that if you're using a machine 24/7, Google will give you a 30% or up to 30% discount based on your machine type and the capacity and runtime of that machine. For example, you run it for 30 days, you're eligible for a 30% discount. The lower the time, of course, lesser the discount, but there's obviously going to be some discount that will be applied based on the usage, right? Of course, there's no discount if you use it for like 1 day or 2 days, but yeah, for longer periods of time, if you're using it, they'll automatically put the discount on your bill, and the bill that you will see is not going to be like, okay, yeah, I spent this much. Google will minus the discount that was applicable based on your machine runtime, and they'll and you'll only have to pay the discounted bill, which is great. I mean, no other vendor provides that. We also have something called preemptible instances as well. Preemptible instances are great because they can offer you up to 80% discount. So let's say an instance per hour was like $100 per hour. I mean, $100 is like lots and lots of money per hour. But let's say, that's just for the sake of convenience, let's say there is an instance which is $100 per hour, right? So with that instance, if you preempt it, then what happens is that you can get it for like $20. Instead of paying the entire $100 bill, you'll probably pay $20, right? The problem with that is that there are no SLAs. So if something were to happen to that machine, it will be terminated automatically by Google. And that's what it means, that there are no SLAs. So Google does not guarantee that, that machine will continue to run. So you can obviously lose your data as well. And obviously, you can, obviously lose the machine as well, which can cause downtime. So definitely not a machine that you will run in a production environment, but it can be used in production environments as well, with mission critical environments, if you actually integrate this properly with scaling policies, right? So in that case, you can use that and make and save lots and lots of money there. Do we need to do anything else to set that up? So there's a follow-up question on load balancing. Do we need to set up anything on that? For the load balancer, yes, you do need provision the load balancer, right? But apart from that, nothing. For the instances, we have a concept of instance groups, or I would say managed instance groups in this case, right? So to make sure that obviously load balancers availability will be managed by Google because they will automatically scale the load balancer as per your requirement. But if we talk about like instances, Google has no, if you do not have any additional auto scaling, then Google does not provide any, additional availability for your instances. What you need to do is you need to use something called instance groups. And in this case, it will be managed instance groups. With managed instance groups, you should be able to create instances and scale them accordingly. So you have availability across instances for instances as well, and for your load balancer, which is like built by Google, and then you can have a solution which is like highly available in nature, or also supports availability across multiple regions as well. In this case, right, because you have a global load balancer and you have instances that have instance groups, and they can also scale across different regions, making sure that you do not, in case a particular region is down, you do not lose the entire capability of your workload. I hope that answers your question, everyone. Right. So we did talk about, instance types, like how many different types of instances are there, how many instance types are there, right? So there are certain categories, right? The categories are divided into CPU, right? High CPU, or you can even call that as CPU optimized, right? There are high memory, which are memory optimized. So high CPU, like you have calculations happening. You have lots and lots of applications that use lots of CPU, arithmetic operations and stuff. Obviously, those are the machines that will fit your requirement because they have a higher ratio of CPU towards the RAM. Because for these machines, you need more CPU than you need RAM. So they have higher ratio towards CPU versus RAM, something like 6 cores and 6 GB of RAM, right? Something like that, right? Then we have high memory, which has higher ratio of memory because this is a memory intensive workload, something like 4 CPUs and 16 cores of RAM. That's what I mean when I say higher ratio of one attribute towards the other. In this case, it will be higher memory to the ratio of CPUs. Then we have standard, which are like standard workloads like small web servers, small application servers, small database servers, which has like a balanced ratio of RAM to CPUs, right? And then we have shared code, which are basically this code will not be fully allocated to you. It will be shared across different machines. So those machines could be used just for something like jump server and stuff like that, like small workloads. You only go there to, jump into or log in into some other machine. So stuff like that could be shared code machines. Now, one of the other factors that we have inside of Google Cloud and is only supported within Google Cloud, and it's pretty amazing. And I'll show you during the demo section as well, that you have the capability to create custom machine types. Whereas, like, okay, I mean, this if you have worked in cloud before, any cloud, one of the problems that all cloud architects or all cloud engineers have faced is that, okay, the machine that I was migrating from on-prem or any other environment to Google to the cloud platform was like having 16 cores and 56 GB of RAM. Now, if I go to the cloud platform and look for an equivalent machine type, there is none, right? That's a problem, right? I mean, you either have to create a smaller instance and live with the performance issues, or create a larger instance and pay more for the additional resources. And that's obviously a challenge. And that's where, custom machine types is something that's pretty amazing. And I really love this feature because it allows you to pick your own CPUs and your own memory that you need. And you can create a machine type on exact that configuration that you have picked. So there's a slider that you can go through a slider and increase RAM and CPUs accordingly and allocate it. At this point, we've already discussed that, when we talk about CPUs versus vCPUs, one vCPU is basically half of that of a full physical core that you will actually get on-prem. Right, let's talk about disks. There are quite a number of disks that you can actually attach to a virtual machine. There is standard PD, which is, again, PD stands for persistent disk, right? There is standard PD, which is basically your hard disk drives. There's SSD PD, which is, again, PD stands for persistent disk. Let's get that out of the way first, right? Then we have SSDs. Now, SSDs are faster drives, right? Solid state drives. Again, they are the faster drives. And we have balance, which offers you balanced performance in terms of input and output operations per second and disk throughput, right? I mean, if you try and measure a performance of a disk, the disk performance is measured in terms of input-output operations per second and the throughput that the disk offer when you're transferring data in or moving data out of the disk. So that's how you basically measure the performance. These are the two attributes, right? So balance offers SSDs, they offer you like high IOPS. SSDs offer you like, balanced throughput. Balanced SSDs offer you like balanced IOPS and balanced throughput. Extreme PDs, like obviously they're going to be expensive, but they are very, very fast in terms of IOPS, like very high IOPS. And local SSDs, local SSDs offers you like some million IOPS, right? I mean, they are amazing. I mean, they offer you very, very fast performance, like flash drives and stuff. But the problem with that is that they are ephemeral in nature. If your machine were to stop and start, right? I'm not saying restart. I'm saying stop and start. In that case, your data on that local SSD will be deleted automatically, right? So again, obviously, it's not like a solution which you can use for persistent storage solutions, right? But apart from that, since it offers high amount of IOPS, there are definitely needs in environments where you can use this as well, right? The other thing is that you can resize the disk. When we say resize, you cannot decrease the size of the disk. You can only increase the size of the disk without any downtime. So let's say you have a 10 GB disk and you want to increase it to like 20 GB or 30 GB. That can be doable without any downtime. And even if you have additional disks, not the OS ones, like D drive, C drive, or any other mount point that you have inside of Linux, you can detach that, move that to another instance, and mount it on the other instance and bring it online over there as well. And that also incurs no downtime whatsoever. There are certain vendors where if you try and resize the disk, it does require you to stop the instance first, right? But it doesn't happen inside of Google Cloud Platform. Right. Different types of disk. Like, okay, what are the types of the disk? And I mean, we talked about a few of them. We talked about standard. We talked about balanced. We talked about SSDs. We talked about extreme, and we talked about local SSDs, right? But what's zonal and regional? I wanted to clarify this concept as well. Like, we have for each disk type, except for the extreme and SSDs, local SSDs, because again, we talked about like those are flash drives and stuff, and they need to be very high performant, right? We have concept of zonal and regional drives. Now, zonal drives are created. So if you remember from our initial session, we talked about that in Google Cloud, we have regions, and underneath that we have zones, and zones are built to like offer high availability, right? So if you have two virtual machines or you have two resources, they can be spread across two different zones and can be replicated to offer you high availability, right? That's great. But what if you have resources within just single zone? Then you have absolutely no high availability. Of course, that data will be replicated within that data center, but if the entire data center goes down, then you lose your entire data set, of course, and there's no availability, right? So we have two types of disks. We have a zonal disk, right, which basically within a single zone. So it does not span across a single zone, and they're efficient and they're very reliable, and they offer very fast performance in terms of how fast a hard disk drive can go, right? And we have a regional standard PD, which actually automatically creates a disk which is automatically replicated across two different zones within a region. So they have some high availability built into them. So they have built-in replication that allows you to create a disk in a region with two availability zones will be syncing that drive. Same applies to balanced PD and same applies to SSDs as well, right? But since zonal extreme, because think about this, like two different zones, there are two different data centers that are maybe 100 miles away from each other, or maybe 20, 30 miles away from each other. And this data replication happens over the iSCSI protocol. And however fast the network, there will always be some latency when trying to replicate data from one location to another. So if very high performance needs are required, then you cannot span your disk across different zones or different data centers, right? That's why zonal stream PDs and local SSDs, which are very, very high performant, they cannot be spanned across multiple regions. Of course, you can build your own iSCSI protocols on top of this to replicate this, right? But that's no solution that is kind of built in. I mean, that will obviously defeat the purpose of actually having them in the first place. But you get the idea, right? If you need a disk that is very high in terms of IOPS, you can always use zonal extreme PDs as well. And the cost also varies from if you go to the left-hand side, the cost is the lowest, and if you go to the right-hand side, the cost keeps on increasing, except for the local SSDs, which has a fixed cost that is built into the instance itself. Right. They also have their minimum size that you can allocate and their maximum size, right? So there is, extreme PDs, except for others, need to have like a 200 GB size minimum, and local SSDs have a 375 GB size fixed. So it's not like you can increase the size or decrease the size. It will be fixed size for these flash drives that we talked about, right? And the maximum capacity can go up to 64 TB for all of these, except for local SSDs, right? So quite a lot of options, right? Even a single disk can be as big as 64 TB, and you can attach lots of disks to an instance as well, which allows you, lots and lots of capabilities in terms of storing data on top of Google Cloud for your virtual machines. Right. Any questions so far? See none. I mean, if you have questions, just type them in, and I'll answer them after this slide. Okay. As far as the pricing goes, the pricing is by the second. I think again an old slide, not updated, but yeah, I mean it's by the second. You're still billed for minimum of 10 minutes, and after that it is by the second, not by the minute. So I think there's a correction over there I need to update. And then we also talked about like sustained use discounts. So you do get discounts if based on your usage. So if you have an instance that is running 24/7 for 30 days, you're eligible for a 30% discount. And I'll show you all of this in the console as well. Like, they'll show you that if you run it like through this period, this 30% discount that is applicable to the instance. You have preemptible instances. We did discuss about them, like they have no SLAs whatsoever, but they can offer you up to 80% of discount, right? And there's just one single checkbox that you need to click in case you want to actually use them. Now, to save money, you also have custom machine types. Instead of going with a predefined machine type, you can, pick up only the CPUs and memory you need, and of course, then you can, uh, uh, only pay for the resources that you actually purchase from Google Cloud for a particular period of time, right? You also have the recommendation engine that we talked about, which will, let you know if there are any underutilized instances. So you can lower the size of those instances and save money. And we also have committed use discount, which is like a reservation. You can go and say, okay, for 1 year or a 3-year term, I want to purchase this instance, and you will be eligible for a 55%, up to 55% discount if you make that commitment. Of course, larger the commitment, the better the discount that you will get. Right. So that's all we have in terms of the explanation. We'll do the demo now. I'll just close this out and save. And let me bring in the demo sheet. That's not the one. Getting started. All right. So that should be our demo. This is where we can, do the demo. I mean, I have a project already allocated for this class, and it's going to be valid for, I guess, a couple of hours, so that we can do and show you how to create a virtual machine, right? So we're not going to go into the networking section of this. We're just going to simply use the default network today because we already looked at that yesterday in the webinar related to networking, right? So we'll keep this strict towards virtual machines, right? So we'll go and create a virtual machine. To create a virtual machine, you will obviously first need to select a project, then go to the navigation menu and go to compute engine. And then underneath that, you can look at virtual machines, VM instances. And within that, you will be able to create your virtual machines. I'm going to click on virtual create instance. In case, a question might come to your mind is like, okay, what if we have virtual machines on-prem and we want to import those virtual machines or migrate those virtual machines inside of Google Cloud? That's completely doable. We have something called Migrate for Compute Engine, which allows you to migrate hundreds of instances within Google Cloud using disk-based replication. And we also have, if you have like offline migration, you can take a backup or take a backup of your VMDK or VHD files, upload it to cloud storage within Google Cloud, and then use the import feature within Google Cloud to import those for offline migrations as well. So even if you have workload that's outside of Google Cloud and you want to bring them in, there are a couple of options that allows you to do that. Or you can do a side-by-side migration, which is basically creating a machine over here and then just migrating your application. So I mean, it's just 3 that we quickly talked about. Right. So the first thing is that you add a machine name, right? Specify the region and the zone that you want to specify this machine in. Let's say I want to specify this in US Central and US Central A. Now, one thing to keep in mind is that all the machine configurations that you see over here might not be available in all the regions because, again, these are data centers, right? And all data centers might not have the latest technology. So you might not see the same capacity or same instance types across all the regions. Now, I know for sure that US Central has all of them. That's why I always demo for US Central. I can show you the maximum capacity of the maximum attributes that you can actually choose when creating an instance. Right. So we talked about like standard in these machine types and stuff. Right. Over here we have series that you can choose from. We have CPUs that you can make selection based on their availability. We have N2 instances, which are Intel Cascade Lake, the latest series of processors. We have AMD processors as well. We have first generation, which allows you to choose the CPU platform, which could be between Skylake, Broadwell, Haswell processors, Ivy Bridge, Sandy Bridge. If you don't know what they are, I would recommend that you quickly do a read about them, but think of them as like your desktop class. I mean, these are like different classes of processors. For server class, like you have in desktop class, you have i3, i5, i7, i9, and so on, right? Similarly, we have like these classes for servers. It's for servers themselves, which are basically allocated by Intel, right? And then from there on, you can pick up your machine type. We have standard, we have shared core, we have high memory, we have high CPU, just like we discussed, right? And then you can also have the custom type where you can go and select custom and you say, okay, I need, okay, let's say 42 CPUs and around somewhere around, let's say 190 GB of RAM, right? Great. And I can pick that configuration and based on that, I can create the instance, right? So it's super awesome, like, the capability to get the number of vCPUs so you can select them and then allocate them accordingly, right? So I've not seen this feature yet in any other cloud platform. So it's really great to have it, right? And if I were to go to N2, N2 also has the same capabilities. Like obviously it gives you custom machine types. It also gives you standard high CPU. But again, you're using the faster version of the processors. It's latest generation and it uses the Intel Cascade Lake processors. If you want to save some money, obviously a good idea to use AMD processors because AMD processors are a little bit cheaper instead of using the Intel processors, right? Of course. And then again, same type, standard high CPU, high mem. We also have some large instance types as well, which is under compute instance, compute optimized, which offers you up to 60 vCPUs and 250 GB of RAM. And then we have very large instances under mega memory and ultra memory, which is memory optimized. Now, I do know that we did not talk about this in the slides, but I just wanted to show you this. You can have instances which can range up to 160 vCPUs and 3.75 TB of memory that can be allocated to a machine, which is pretty large, and of course will have a huge cost associated with it as well. If you want GPUs associated, you also have that capability. You have NVIDIA and you have NVIDIA 800 and some of the previous, some of the other that is compatible with Skylake CPUs. So you can pick those up and see, okay, which machine type you need, and accordingly you can, pick that up. Even with your other machine types, for example, if you're using N2, right, and you're not looking for a GPU optimized instance, but you're looking for a general instance and you want to attach a GPU to that, you also have that capability. You can simply say, okay, N2 doesn't have one. I think N1 used to have one. So with N1, you can add other GPUs as well. You can say, okay, I need, these many GPUs. Instances must have 24 crores. So let's pick that up. Instead of getting a custom one, we'll just get this and change this to Tesla K80, Tesla 800, T4. I mean, you'd have to do the combination of and read the error message as well, because there is obviously a limitation because they're trying to push you to use the GPU instances. But again, the idea is that you can still, with the correct instance type, you should also be able to attach GPUs as well. Right. Then come the boot disk. Any of the options, if it's not discussed, it's just outside the scope, and that's why I'm not intentionally discussing it, right? But you can read about them. Obviously, there's a question mark option over here. So if you want to see, okay, what this option does, obviously you can read about them as well. But again, I'm just leaving them out because they're outside the scope at this point of time. Then choosing the boot disk is basically where you allocate that image that we talked about, right? And this is where you will get your image, which is basically choosing the operating system. The operating system could be Debian, it could be CentOS, it could be Fedora, Deep Learning on Linux, and there are so many options, right? I'm just going to go with one of the options that I like the most, which is CentOS and CentOS 8. Now, you also have Windows-based instances as well. And over here, you can choose the version. Let's say you want to go with 2019 data center and attach the disk accordingly, right? Now, I'll just go with CentOS 10 just to make life a lot more easier. Right, and you have options for standard persistent disk, you have SSD option, and you have a balanced persistent disk as well, right? You do not see local SSDs or extreme SSDs over here because, they do not need that kind of, these just do not need that kind of capacity. And of course, your, what you call that, your OS cannot withstand local SSDs, of course, because if this instance stops and starts, the entire OS files and everything is kind of, gone. And your instance will never be able to come online anymore, right? So just going to go with SSDs for now and allocate 20 sites, but you can also create your own images, use your own snapshots or disks that you have stored somewhere to create, OS drives as well, which is awesome. If you need to assign this virtual machines permissions to access other resources inside of GCP, that can easily be done. Okay, let me actually do the size that I mentioned that. Sorry about that. So if you have other machines that needs access, this virtual machine needs to access without having to specify a username and password, the way to do that will be using a service account. and I'm going to try and set some access, let's say, for example, to cloud storage. And I want to give read-write access to cloud storage for the service account, the default one. So I can do that as well. Inside management, this is where you can, if you have a reservation, you can allow that. You can also enable delete protection, so no one can accidentally delete your instances. If you have reservations that you have purchased, like we talked about earlier, you can also allocate those over here, but I do not have one, so that's why it won't appear over here. This is where you'll provide the startup script, any custom metadata that you would want to provide. Then availability policies, and this is where you would preempt the instance in case you do want to use preemptability. And something very nice is that over here, it tells you the cost, right? And it also gives you the overall, and there's no such change use discount for this because this is a preempted instance. So there's a cost associated with this, which is around this much. And if I were to go and unpreempt this, let's see, off, go up there, and you can see the charge has increased to like $60 instead of 20, and there is a sustained use discount, which is like 20% discount on this instance. Again, it does also depend on the instance type as well. Okay, but there are instances which offers you like 30% discount as well. So let's say, for example, if I go here and pick this up, for example, 15 GB, you'll see that this is offering you a 30% discount, right? It does change with the instances, by the way. Right, I'm just gonna go with standard now. Right. You also have like what happens if there is an on-host maintenance. You can pick live migration, and if something were to go wrong to your instance, you can also have automatic restart turned on as well. Some of the options that we discussed earlier. Right. Now coming to this, you can attach this like other disks, and one of the good things that I really like about GoCloud is that by default, any disk that you create or any storage solution that you have inside of Google Cloud Platform, all of those solutions are encrypted by default. So there is no way for you to say that, okay, I do not want encryption. Encryption is built in, and you have to use it, right? So either Google will manage the encryption for you, or you can upload a key inside of Google, or you can create a key inside of Google's key management service and use that key, which will be purely managed by you. So that could be used for role separation, or it will be just a key that you have supplied at the time of creation of the disk, and this will be encrypted, and your application will need to decrypt the data on the disk at runtime, and Google will have no way to decrypt the disk. You have all three options available here. Right. So let's try and attach additional disk. Just gonna try and attach disk one, and there you see you have all the other options that we discussed about. You have balanced persistent disk, you have SSDs, you have standard disk, you have local SSDs, and you have extreme persistent disk as well. Let's go with SSD persistent disk, right? And there you can, pick up your options that you would want. And after you have picked up your options, like, okay, is it going to be read write? Is it going to be, if the instance gets deleted, do you want to delete the disk or keep the disk? The size of the instance, and as you can see, the larger the size, the better the number of IOPS that you will get on the disk, right? And this is offering us up to 15,000 IOPS. Let's see what happens if I go to extreme persistent disk and get that much amount of size. You can like say that, okay, I need these many number of IOPS, right? And pick that option. Obviously, we have the largest number, and that's why I typed this in, because I want to see what the largest number is. So the maximum number of IOPS you can have is around this much for your own capacity that you want to choose. I'm just going to go back to standard disk, and not even standard, balance probably, and pick a small size because I don't want to incur large amount of cost. But yeah, you do have options if you want to do that. There is a multiplication factor. So if you're doing, this standard persistent SSDs, the multiplication factor is size of the disk into 30. And if you do balance this, then size of the disk into 6. That what helps you calculate the IOPS. And remember, this was the attribute that allows you to, calculate. This was the attribute that allows you to calculate the performance of the disk. Right? So I'm just going to choose balance disk for now and say done. Right? I'm going to leave the networking options for now. We kind of discussed those yesterday anyways, right? So I'm just going to leave them on, leave them like they are. And in case you want like sole tenant nodes, which is like physical servers inside of Google Cloud, you can also have that capability as well if you want, right? But I don't want that. I don't even have the money for that. So I'm just going to, for the test environment, I'm just going to create a small instance with, the default options and say create. And that's going to go and create the disk, a couple of disks, of course, and also going to create the virtual machines, which I should be able to connect to, right? It's going to take a couple of minutes before the machine is completely online, right? And if you have any questions, meanwhile, you can definitely put them in the chat window. We're almost, there at the end of the session. The next thing I want to show you is like how you can increase the size of the disk and stuff, and obviously how to connect to these disks as well, connect to these machines as well. Right, so the instance seems to be created successfully, instance 1, and we have information and we can SSH into it if you want. Now, I'll just do a quick SSH, and while that opens up, I'll show you like how you can see the disk and how you can resize the disk without any downtime. For example, this is the disk 1, the additional disk I added. I want to increase the size of the disk. So let's open the disk. And let's see where we can go ahead and edit. And instead of 10 GB, I need a 20 GB disk maybe, and say save. And as soon as the save is done, we should be all good. And the disk size will resize automatically without us having to, incur any downtime. Right. So that should take care of resizing of the disk. And this is the additional disk. You can also do the same for the OS disk as well. And that does not incur any downtime whatsoever. Right. And slowly, if you do a few refreshes, you'll see the size of the disk has increased to 20 GB, which is great. Right. So the next thing that you can do is you can also take backups of the disk. For example, you want to take, you want to make sure that you have some changes on the disk and you want to preserve those changes. Right. How do you do that? You can go and say create snapshot. Let's say snapshot 1 for disk 1. Pick up the source disk 1. Where do you want to store it? Maybe multiple regions for higher availability, or just one region. For higher durability, not availability, right? And then say create. And what this will do is it will just go ahead and create the backup of that disk for me, right? And backups are compressed, so they don't even take a lot of space, and they are stored in a Google-owned bucket, which is going to be on cloud storage for your account, right? Which is amazing, right? And as you can see, the drive has successfully been, the instance has successfully been launched, and we are ready to go, right? So what we're going to do is we are going to, do a couple of changes here. And if you need to connect to these instances, of course, keep this in mind that for Windows, we need to use RDP, and for Linux machines, you'll use SSH. Right. So what we're going to do is sudo yum install httpd. Why? So we're going to promote this server to a web server. So we can also see this instance in action as well. Right. And then the next would be sudo check config httpd on. So I'm basically making sure that the service is set to automatic. So even if the server restarts, it comes online. And sudo service httpd start. So let's start the service. And sudo vi bad html index.html. And we're going to type something in here. Insert hello from SkillUpRight. Hope you enjoyed the webinar. Thanks for attending. And that should be it. So I think we have the instance up and running. And if we go to its public IP and try and browse that, it should take us to that cool little web page that we created. Let's check that out. think we probably might have missed one of the rules, which is going to be, you need to make sure that HTTP rule is allowed. Edit. And after editing, let's go ahead and make sure that the rule is turned on, which can be done by this is going to basically create the tags that we talked about yesterday during our networking webinar. And say save, and that should do it. Yep, hello from SkillUpRight. So hope you enjoyed the webinar. Thanks for attending. That's what we did. And that marks the end of the session. I do not have anything else to show you guys. If you have any questions, I'll be happy to answer them. So keep them coming. Oh, okay, so there is a question about I missed today's session. Can I get day one in today's recording? So check with SkillUpRight. They have posted links in for recordings. Keep track of that link. Yeah, I mean, keep track of these recordings with you. You'll probably be able to review all of those. There is a question like quick recap of last 3 days. Yep, for sure. So we started day one with introduction. We looked at with Google Cloud, how many services there are. And we looked at services like from the compute perspective. We looked at services from the storage perspective, like databases and unstructured data, SQL, NoSQL, all of that, and big data as well. Then we looked at machine learning and big data services within data warehousing, data transformation services. We looked at the entire umbrella of services that Google has to offer within different domains, right? So I mean, that's what we discussed in terms of like what all services there are in terms of introduction. We also talked about like why Google Cloud is a global leader in terms of, and how it is like a game changer when it comes to like doing networking with Google Cloud because of that global network and how it is being offered to you as a service, right? So that's again another, option as well. Another thing as well that we discussed, right? Then we also talked about like some of the other introductory things like regions, zones, and stuff, like how data centers are laid out and what's the structure like for Google Cloud, right? Then going into the day two, we talked about networking. For networking, we talked about like how to create VPC networks, how to create routes, how to create firewall rules, how to place your instances inside of those networks, which allows you to create network designs which are both highly available and can also offer you disaster recovery, right? And we looked at how to create those networks yesterday as well, right? And going into today, we talked about virtual machines. So we looked at like, okay, how to create virtual machines, what all things are involved with virtual machines, right? And then we looked at creating a virtual machine. We also looked at like how do you attach this to those virtual machines, how you can expand those disks as well. And we also looked at like promoting a virtual machine to a web server, and we browsed it and it was working perfectly fine, of course, after adding the firewall rule, right? And that's, that's where we wrapped up the entire session. Hopefully that should summarize what we all covered in the last 3 days and should be a good recap for you guys. So there's a question from Jalashmi. So check out the link that's been posted by SkillUpRight, which is www.skillupright.com/events, right? It's been posted in the chat. Keep track of that link, and that's where you'll find links to the further recordings, which I think is on YouTube, right? And you should be able to view those over there. Apart from the video, we need these slides also. So Sachin, I'll work with SkillUpRight to see how this slide can be shared with you guys. And yeah, of course, we'll try and wait and figure out like how these slides can be shared. Trying to see if I can upload it over here, but there's no option. But yeah, we'll work with the SkillUpRight team and see how the slides can be made available, right? And of course, the recordings are always available at SkillUpRight slides at the /events. So do check those out. Recordings. You're welcome, guys. Hopefully you enjoyed the session and it was meaningful and informative for you guys. Any other questions are most welcome before we wrap up the session. We're going to be wrapping up pretty soon. So if you have any questions, now will be the good time to ask. How many days will it take for someone to be associate cloud engineer? I think what you mean is like get certified for associate cloud engineer, right? So the answer to that question is like in terms of training, I think a couple of weeks, right? But in terms of exam preparation, I would say a minimum month. But everyone has their own pace that they learn at, right? So I cannot put a number on that. And also depends on your experience as well, because it does go into a lot about Kubernetes as well. I mean, not a lot, but there are things that you need to know about Kubernetes as well, like specific commands and stuff, and also need to have some hands-on experience on G Cloud commands as well. So unless you have some hands-on experience on that, it probably might take you a little bit more time than, I guess, 1 month. So again, I cannot put like an exact number on that, but if you have some Kubernetes experience and if you have some sysops experience, it should take you around 1 month. That's what I would say, but that's just my perspective. You're welcome, guys. Thank you for attending. I guess last chance to put any questions forward. What are different certifications? Yeah, that's a good question, Sachin. I like to use this link whenever I need to look at like Google certifications and training, and this is probably the most elaborate way to find information about certifications, right? Let's get past through all of the ads and go to training. Right, okay, cool. So here, if you scroll down, go to certification. I'll just post this link for you in the chat. Make sure to collect that. Keep it handy. Otherwise, you'll obviously always have to scroll past those apps before you reach this point. And there you can see all the different certifications like foundational level, associate level, and professional level. The good thing about this is that if you click on a particular certification, like cloud engineer, and going in there, if you scroll down a bit to the point where it says start preparing and click on that, which is a step 4, you will find the learning path. I mean, what's the recommended Google's learning path, what courses are involved, all that information is available, and the objectives and what will be you be taught in that course. If you click on learn more, it will open up another link, and this link will give you complete information on, okay, what course will be there and what will be taught in that course, and then you can, even sign up with this course, like going to take this course on demand, or obviously SkillUpRight will always also be, helping you enrolling into these courses going forward. So again, this is a quick way that you can find out all the courses. But just to give you an idea, there's one related to solution architect. There are data engineering and machine learning, DevOps, security, networking, and associate cloud engineer and collaboration engineer. And there is one more, which is the foundational level that we just looked at, which is the what's that one called? The foundational digital leader, right? And there's also a fellow program, but I don't think so. If you're just getting started, this is like, I mean, don't even think about it at this point. It's going to be very, very advanced. When you are a pro GCP, personnel, you can even think about this as well, which is like the most advanced certification that you get. Do we have any option to start course on GCP? Yes, of course. Talk to guys at SkillUpRight. They will be guiding you on how to enroll and when will the program be starting, and when will be taking enrollments, and you can sign up for those. And from there on, you be enrolled in the specific courses that will have on GCP. All right, hopefully I've answered all of your questions, and you guys have learned something out of this session. And thank you guys for attending, and we'll close out the webinar for now, right? And thank you guys. It's bye. It's a bye from me.